So I'm going to stop sharing my screen, and Matthew, if you want to start sharing your screen, that would be great. So I'd like to welcome you and thanks for coming to talk to us today.
No problem. Let me just find. Go there. Okay, can you see the presentation there?
Yes, I can. Yep. You just need to put it to full screen.
Yeah. Okay.
So brilliant.
Yeah.
That's perfect. Thanks a million. Nice one.
Okay. Well, thanks, Emma. Thanks, everybody. Thanks for the invitation to come and talk to you today. So as Emma mentioned, I'm going to talk to you a little bit about kind of addressing climate action, particularly looking at peatlands and the role that peatlands play in climate mitigation and adaptation. And I'm going to kind of focus it on some of the work we're doing at the moment through the EPA-funded SmartBog project. So, I'm coordinating the project, but obviously it's not all my work. And I would just like to acknowledge the multitude of authors that are below the title there who are all contributing to the work itself. I'll just say a little bit about kind of, peatlands, in terms of kind of their background and importance. So, these are ecosystems that are forming in areas of high precipitation where we have drainage that's impeded. And we kind of want to see the kind of in natural condition, these key peat forming species, the sphagnum mosses, the cotton grasses, such as Eriophyllum, for example. And this then builds up into this kind of really significant layer of carbon rich, dead and decaying plant material. Now, in relation to the ecosystem services and the natural capital, that's really the focus of these sorts of workshops. These types of ecosystems provide a multitude of ecosystem services. The one that I'm, focusing largely on in this talk is carbon and climate change and greenhouse gases. But in terms of carbon sequestration, peatlands are incredibly important. If we look at northern temperate peatlands, they hold 25% of the global carbon stock. In Ireland, they're hugely important as well. They hold nearly 75% of our soil organic carbon stocks. So in terms of carbon stocks and climate change, peatlands are incredibly important. In relation to some of the other aspects that Ian has spoken about in terms of kind of natural capital and ecosystem services, they're also really important in terms of water quality. There's lots of information out there in terms of how peatlands influence the quality of water and the need for water treatment, for example. They're also important in terms of catchment scale hydrology, in terms of contributing to that process of flood management. They're incredibly important in terms of biodiversity, in terms of the flora and fauna. Botany and Mona are tweeting today in terms of some important bird species that are potentially nesting on some of their rehabilitated sites. But they're also very important from a cultural and recreational perspective. And there's a really kind of strong kind of linkage there between people's perception and culture and peatland ecosystems, which has to also be considered. Now, in Ireland, the peatlands cover about 21% of the land surface area, and that's a mix of raised bogs and blanket bogs and some fen areas as well. But many of them are degraded. Nearly 85 to 95% of them have been degraded in some way, shape or form. And that's really due to drainage. And it's drainage for agriculture, it's drainage for extraction for energy and horticulture. And in the Galway area, there's probably an awful lot that's been drained and converted to forestry. But on the back of that, and this kind of resonates with lots of the kind of key issues that you've raised, I think, in terms of your assessment of kind of, climate proofing particular areas, these sorts of peatlands are incredibly vulnerable to climatic variability. So they're going to change, their form and function will change in relation to climate change. And this has, significant implications because it has this real kind of positive feedback loop on climate change and climate mitigation. But as you are all probably aware, from a national perspective at the moment, there are relatively low-hanging fruit in terms of, the opportunity to reduce emissions and particularly to focus on those sorts of peatlands that are degraded and extensively degraded, because we can make some really significant emission savings in those areas. And this is a slide that I put up quite often because I think it really, shows the importance of peatlands in terms of the kind of the climate mitigation, climate emissions piece. So if you look at the left-hand side of the graph here, we have a near natural bog, and essentially anything that's negative has a net cooling effect on the atmosphere, and anything that's positive above that zero line has a net warming effect on the atmosphere. But you can see, a natural bog, it stores and assimilates a lot of carbon. It releases a bit of methane because it's a wetland system, but its net GWP is negative. So it holds and draws down more carbon than it releases to the atmosphere. So it has a net cooling effect. But as soon as we drain those bogs, as soon as we open up these systems, drop the water table, all of that carbon that's held within the peatland system can start to be mineralized. It's converted to carbon dioxide and it's returned back to the atmosphere. And these systems are still relatively wet, so they still produce methane. So we have a loss of, if we drain a bog, we have a loss of carbon, a loss of methane from the system. So it has a significant warming effect on the atmosphere. Now, as soon as we decide to do something about that, very simple kind of rehabilitation approaches, blocking drains, starting to re-wet the system, it's almost like turning down the dial. We can really slow down the losses of carbon to the atmosphere. We will still see methane emissions. So in the short term after rehabilitation, we still see a net warming effect on the atmosphere, but the emission savings are really significant by starting that rehabilitation process. And then over time, as the vegetation starts to come back in, if we can start to really kind of see the sphagnum and the peat forming species coming back in again, we can switch the system back to a carbon sink and having a net cooling effect on the atmosphere. I think it's important to say that it's very difficult to restore and rehabilitate these ecosystems back to their initial condition, but we can certainly put them on a trajectory where they look a lot more like they used to than before we started draining them. And the SmartBog project that we have at the moment, so, we're looking at a whole range of different ways in which we can observe and qualify and quantify the management impacts on peatland function, and using a range of different approaches to do that. And it's really kind of important at the moment because, the new, government framework in terms of how we report emissions from these kind of, these land cover classes is important, and we have to now include these in our national emission inventory. So there's a lot of focus now on peatland systems, both managed and natural systems, in terms of how we progress towards our EU greenhouse gas targets. So what's the SmartBog project doing? Well, we're using a range of different approaches to answer some really fundamental key questions. So, first off, well, where are the peatlands and what condition are they in? Now we have some kind of basic, kind of maps that kind of describe the kind of peatland areas, and we're going back to refine this. So this is really the work of John Connolly, who's joined Trinity College now. But again, using a range of different approaches, using Earth observation data, so using things like satellite-based data and the Sentinel platform that's freely available from Copernicus, and also using near-Earth data as well. So using multispectral data that we can get from drones and UAVs. And it's a really important resource. We have a spatial resolution of about 2 to 5 centimeters using this multispectral data. So we can pick out really key detailed parts of an ecosystem to really understand kind of what's going on there. We can use this information to then help qualify and ground truth where the peatland areas are. We can think about the condition because we're using machine learning tools such as object-based image analysis to detect drains and the frequency of drains and the density of drains and the depth and function of drains. Are they active or inactive, for example? And we can do that using the multispectral data. We can link that in again to ecological status. So as the hydrology changes, the ecology changes, and as the ecology and hydrology changes, the biogeochemistry changes. So we can then link all of these pieces together to really understand, well, what's the ecological status of a near natural versus a degraded bog in terms of the plant species composition, in terms of the area which these plant species cover, and are these changing over time in relation to climate or relation to management, for example. And then we can, develop, these vegetation indices maps for all of these ecosystems that again give us some understanding of things like photosynthetic activity of the plants. We can actually, from space, infer the amount of carbon that's assimilated by these ecosystems. So a range of techniques to really understand where the bogs are, what condition they're in, and how they're functioning. We're then overlaying that an observational kind of, series of sites that are looking at the carbon and greenhouse gas dynamics of these systems. And this will range from near natural bogs to degraded bogs, which are essentially the industrially mined sites, to some sites that have been rehabilitated through both just drain blocking and letting vegetational succession take hold, but also some of the new approaches using enhanced rehabilitation, where we create bunds and berms and then inoculate these areas with sphagnum. But the point there is to understand at each of these trajectories, what are the carbon and greenhouse gas dynamics? Are we assimilating more carbon and storing more carbon than we're losing? Are we losing other greenhouse gases through methane from particular plant species, for example? And also we're looking at the fluvial losses as well. So we're looking at water quality there and looking at how much particulate and dissolved organic carbon is leaving the system. We're also using new approaches using the Internet of Things sensor design. This is something that you guys in Galway will be very well familiar with, because Galway Bay has been a real test bed for this sort of technology. So these are really kind of cheap off-the-shelf sensors that we can then deploy across different sites within a site, for example, with our gold standard flux towers, to use cheaper sensors to actually measure the key variables we need to be able to predict things like water tables or temperatures or greenhouse gas emissions, so that we can instrument a larger area or many more bogs to help that kind of spatial upscaling. And then we're bringing it all together using kind of machine learning tools and an interactive stakeholder platform that will provide the data to people that really want to use it. So we're providing maps of the site and the details of the site, the metadata and the carbon and greenhouse gas data will be available from the sites, the ecological habitat information as well, from the ground truth surveys to the remote sensing data, which means we can build these different levels of complexity of the sites that we're measuring. Here's some examples of where we're at so far. So here we've developed this new land use map, which we derived from the Landsat 5 data and ground truth with the current peatland map to understand, well, where are the peatlands and what kind of use are they being used for? So we can see the forest systems and grasslands and industrial sites, for example. We're also using the Sentinel platform to create these NDVI maps, so we can actually assess the productivity of these sites over time. We're looking at a range of different sites, as I've mentioned, from kind of the near natural to the industrially mined to the rehabilitated sites, using eddy covariance techniques, which essentially allows us to understand, how the bog is breathing, how much carbon and methane, for example, are being released from the ecosystem to the atmosphere, and how much is being assimilated by the ecosystem. And we're using chamber systems to look at point sources from particular ecotopes of vegetation, and also quantifying those losses through the fluvial pathway as well. I think it's also important to kind of put in here, because you've mentioned this in your strategies, that we need to think about the resilience of these systems in relation to climate change. Here's a really nice paper that's shown the temperature and precipitation anomalies of temperature and precipitation across Europe for the last number of exceptional climatic events that we've had. So you can see, over the last number of years when these exceptional climatic years have been recorded, but in particular, 2018 was a key year for Ireland, where we saw an increase in temperature and a decrease in precipitation. And we were fortunate enough to be able to capture this at one of our SmartBog installations on Clara. So here you can see the precipitation for the 3 years, 2018, 19, and 20, and the 30-year mean. And you can see there was a significant reduction in precipitation in 2018. It was about 300 millimeters lower than the subsequent years, so quite dry. But what happened really importantly here is that this is the water table height on the right-hand side of the graph. And you can see that the water table drops below 5 centimeters for a really significant period of 2018. And it was below 5 centimeters for about 150 consecutive days, which is really important for peatland ecosystems. And we use this kind of, threshold of 5 centimeters to determine dry days. And you can see just how dry and how prolonged that extreme event was. And that had a real impact on the carbon dynamics. On the left-hand side here, for each of the years, you can see the ratio of carbon assimilated through photosynthesis to carbon released through ecosystem respiration. And essentially, anything above this dashed line essentially is driven by gross primary productivity, carbon assimilation by the system. And when it's below the line, it's driven by respiration. And the point here is that you can see in 2018, the system was really driven by ecosystem respiration. It was driven by, as the water table dropped, that carbon was being mineralized from the peatland and returning to the atmosphere as CO2. And on the right-hand side, you can see the cumulative carbon budgets for the years. So you can see in 2018, the vulnerability of the system to climate change. In a dry year, the system acted as a source of carbon. In the subsequent wetter years, it showed the site was quite resilient and it reverted back to a sink of carbon. So we lost about 50 grams of carbon per square meter from the study area in 2018, but in the subsequent years, the system reverted to a sink of about 80 to 125 grams of carbon. So again, importance in terms of the carbon stores, but also important to highlight the vulnerability, but also the resilience of these systems to a changing climate.
Matt, I'm just giving you a 2-minute call
no
there.
Problem.
Perfect.
Last couple of slides. Last couple of slides.
Perfect.
Yeah.
Brilliant.
So here, just important to think about the plant species. So at the top graph here, you can see the green dots here. This is Eriophorum vaginatum. This is the bog cotton, and you can see the influence that bog cotton has on other greenhouse gases, such as methane emission to the atmosphere. So it's important to think about the ecology when we think about carbon greenhouse gas dynamics. But it's also important to think about the fluvial losses. So it's important to think about, when we've measured Clara Bog, for example, we're losing about 9 grams of carbon. From the industrial mine sites, we're losing significantly more, about 20 grams of carbon from that site. All of this builds together, from our remote sensing to our in situ measurements to the Stakeholder platform to provide the information, the Stakeholder platform to those that really need it. And you can see different levels of information here for Clara Bog. So just to finish up then, I've just kind of highlighted and kind of built on the ecosystem services that peatlands provide. It's important to remember they're vulnerable to management. They're vulnerable to climatic variability. The key point here is the hydrology. If you change the hydrology, whether it's through management or through climate, we're going to influence the system. We're going to change the ecology. You're going to change the biodiversity status. You're going to influence the carbon sink strength of the system. We need to be holistic in how we do this. We need to think about all of the kind of carbon dynamics, methane, particulate carbon, dissolved carbon, and also carbon that's lost from standing water bodies. It's a real gap, knowledge gap that we have in terms of the carbon and CO2, methane that might be lost from ditches, for example. But the SmartBog project, we're kind of moving along, as are many other organizations and projects in Ireland, to start, addressing those knowledge gaps and enhancing our understanding of how these systems really function and work and can be used as a nature-based solution in the future.